So how about some synthetic division? Okay, a little different from your long division. Some people like this a little bit more. It's a little bit faster at times. In class, I will actually show you how and why this works, but for right now, for our video notes, we're actually just going to do the process of synthetic division and see what it's actually showing us. So we have a polynomial function, and we are dividing it by x plus 1, and then we're going to write our summary statement in fraction form. So we are going to start by taking your factor of x plus 1. Okay, we're going to set that equal to 0, and I want to solve for x. So I see x is going to equal negative 1. So to start synthetic division, it's a little bit different. It's going to look weird. We're going to take that negative 1 and put it on the outside, and we're going to kind of box it off. Okay. Then the next step is take all of your coefficients from your polynomial. So I'm going to take the 1 from the x cubed, the negative 5 from the x squared, the positive 3 from the x term, and the negative 2 from the constant. We're going to write those down. And you always need to have a value for each one of those things. So if x cubed is our largest power, then I need to have 4 places. If one of those is not there, you need to have a 0 as a placeholder, and that might be something that we want to write down here. So we need placeholders. I'm just going to say for missing terms. And that includes a constant. Okay. So the process of synthetic division, we're going to draw a line, leave a little bit of space so that we can write some numbers in between. And the very first thing we're going to do is bring down the 1. We're going to bring down mama. And then we're going to take this 1, and we're going to constantly think multiply, add, multiply, add. Okay, so again, maybe that's something that we want to write over here. We're going to think multiply, add. That's going to be the process for our synthetic division, which maybe you're thinking, well, that seems backwards from long division. Well, it kind of is, and like I said, again, we'll go through how and the why in class. So we're going to do 1 times negative 1 gives us a negative 1. Then we're going to think add. So a negative 5 and a negative 1 is going to give us a negative 6. Multiply, add. Negative 6 times negative 1 is going to get us a positive 6. And then we add 6 plus 3, that gives us 9. And then we have 9 times negative 1 gives us a negative 9. And then we think add negative 9 and a negative 2 is a negative 11. And I'm going to box in this last number. So this last number that we find here, this is your remainder. Okay. And the rest of these terms that we have found, well, these are going to be the coefficients for the remaining polynomial. And so I kind of think work backwards. So if this is my remainder, then this would be my constant. This would be my x to the first power. This would be my x squared. Okay? So if we were to write this, now they're saying write our answer in fractional form. Okay, well, our answer would be, this would be like if we did long division, this information down here on the bottom is like the number on top of the house, that's your quotient. So our answer in fractional form would be x squared minus 6x plus 9. And now fractional form is going to say take the remainder. We want to add on our negative 11 remainder divided by the divisor. The divisor is that factor, what we were dividing by, so x plus 1. So that is our answer doing synthetic division, writing it in fractional form. Okay, let's try another one. So same thing. So we're going to take this, we're going to divide that polynomial by x minus 10. Okay, so I'm going to start again, take x minus 10, we're going to set it equal to 0, we're going to solve for x and find x is positive 10. So from there, we're going to put that 10 in a little box on the outside, and now we're going to write down all of the coefficients using any zeros for placeholders. So I see cubed is my largest, so I have a 9 for that. Then I go to my squared term, which is a 7. I go to my first power, which is a -3, and I don't have a constant, so we need a placeholder. Okay, so we're going to think bring down mama, multiply and add. So we're going to take 9 times 10, we get 90, and then we add. So adding, we're going to get 97. Okay, do it again. 97 times 10, we get 970, and then we add 967. Do it again. 967 times 10, we get 9,670, and when we add, we get the same thing. And I'm going to box that in right away to say, hey, that's your remainder. Okay, now again, we have to write this in fractional form, so let's think. This first term is my constant, this is my x to the first, this is my x squared. Okay, so if we're going to write our answer in fractional form, so we have our quotient, so we have 9x squared plus 97x plus 967 plus our remainder, 9,670, divided by our divisor, which is x minus 10. And so that would be our answer. That's our quotient for synthetic division. Okay, so this is kind of a nice little process. It's kind of a faster process at times than our long division. And then we're going to use this to do different things like the rational zeros theorem. So it's going to, one thing we want to understand with the rational zeros theorem is this gives us a possible list of potential rational zeros. So right here, this says these are all potential rational zeros. That does not mean that they will be an actual zero. It's just a way to make a list so that maybe we can narrow down what we think our zeros are. Okay? And the way we're going to do that is we're going to make this a ratio. Notice what this is, p divided by q. So where's p coming from? P is coming from the constant. So p is the constant value of our polynomial. And q is going to be the leading coefficient, meaning take your largest power, your largest exponent, and find the coefficient of that. So we're going to do the constant divided by your largest coefficient. Okay, so if we're on the back and we're looking at finding the rational zeros, so first thing I'd want to do is identify the p-value, identify the q-value. So the p-value is the constant, -2. Your q-value is your leading coefficient, which is 3. And we are going to make a fraction. So I have -2/3. And then we're going to find the factors of these. And when I'm thinking factors, we get both positives and negative factors. So if I find the factors of -2, well, your factors would be plus and minus 1 and plus and minus 2. Okay, so we're going to find the factors of 3. That would give us plus and minus 1 and plus and minus 3. Now we want to make all of the combinations of these. So if I were to combine all of these, well, 1 divided by 1, plus and minus 1. I could do 2 divided by 1, plus and minus 2. I could do 1 divided by 3, so we get plus and minus 1/3. And I could do 2 divided by 3, so we get plus and minus 2/3. So these are all potential rational zeros. Okay, so keep in mind, potential. That does not mean that they're all going to work. We want to find if we have any rational zeros for this. So what I would tell you at this point is I would graph your function out in your calculator and I would see, well, what is this going to look like if we were to graph it? Can I find any zeros visibly from the graph? And then I would prove whatever zero actually works by testing it out with synthetic division. So if we take our calculator and we add a graph, and we're going to graph out our function, so we have 3x squared plus 4x squared. Oops, sorry, this should be 3x cubed. So we have 3x cubed, sorry, plus 4x squared. And we have minus 5x, and we have minus 2. We take a look. And I can see it definitely looks like 1 is going to be a 0, and it looks like -2 is going to be a 0. And then I get another one that's crossing, maybe it's -1/3, maybe it's -2/3. Let's at least start with that +1 and let's see what happens with that. So if 1 is a 0, I should be able to prove it's a 0 by doing synthetic division. Okay, so we're going to copy down all of our coefficients, making sure if we needed placeholders, I would fill those in with zeros. And then we're going to do our synthetic division. So I'm going to bring down mama, think multiply and add. So 3 times 1, we get 3, plus 4, I have 7, times 1, I have 7, and a -5, I have 2, times 1, I get 2, plus 2, I get 0. So stop and think. If I have a 0 for a remainder, what does that mean about that 1? It divided in evenly, it is a 0. So at this point, what I have, if I think about writing this perhaps as a polynomial, okay, so I would have this, think about where that came from. That really would come from x minus 1. There's your factor. Think about what we have as our quotient. Left we have 3x squared plus 7x minus 2. So it looked like we had maybe another rational 0 there. If we go back to the graph, it looks like we have another rational 0 at -2. So I should be able to factor out from this, which is really like from this, from our end result from synthetic division, another -2. So let's try that and see what happens. So if I were to go back, let's do it on this side, do synthetic division with -2 on just this part here. So we're going to take all of those coefficients. So I have a 3, I have a 7, and I have a -2. And we're going to do the same thing. So we should be able to test that factor of -2. So 3 times -2, I get and see if that actually divides. Plus 7, I have a So if we start with our synthetic division, we bring down, I'm going to have, so 3 times -2 is a -6. Plus -2, we add, we get a -4. 1 times -2 is a -2. We add, we get a 0. So again, that's telling me that -2 divides in evenly. So now think about what we have. We had that factor from the first time. We just showed that x equals -2 is a 0, which means that a factor would look like x plus 2. Now think about what we have left over. Down here, here's my constant, here's my x to the first. So that's showing me 3x plus 1. So we have just factored out that entire function, and we were able to find all of the zeros. Okay? Now, if we look at this next example, we do the same thing. We're going to find all of the rational zeros. So first we're going to start and say, well, p is equal to -1 and q is equal to -5. So I want to make all of the factors of -1 and -5. So that looks like I'd have plus and minus 1. And on the bottom, plus and minus 1 and plus and minus 5. So not too many choices here. Our choices could be plus and minus 1, or it could be plus and minus 1/5. And again, those are just potential rational zeros. So if we go to graph this and we take a look at this function, so we have -5x to the 4th, and then we have plus 3x, we have minus 1. And we graph this out, it looks like, well, we're not getting 1, that's for sure. We're not getting -1, that's for sure. So our only possible potential rational zeros could be at 1/5 or -1/5. Well, it's not going to be -1/5. In decimal value, 1/5 is going to be 0.2, and I can definitely see it's not crossing at 0.2. So what is it telling us? Well, that's telling us that we don't have any rational zeros. So what we would have is we would have zeros, however, they would be irrational. So I could say after graphing and checking, we have no rational zeros. So if you were to do synthetic division, you would see by dividing them out, you would not have a 0 as a remainder because it would not divide in evenly. Okay, and then the last thing that we can do with synthetic division is we can actually test or prove or show that we don't have zeros past a certain point. So which are called upper and lower bounds. Different from saying a function is bounded above and below. Upper and lower bounds is trying to tell you if you have a function, I'll just draw a quick little graph. If it's an upper bound, what it's trying to show you is there's no zeros past that point. And if it's a lower bound, that means there are no zeros past that point. So in order to do this, we're going to do a little synthetic division. It says we're going to prove all of the real zeros must lie in the interval between -2 and 5. So that means between x equaling -2 and x equaling 5. Meaning -2 would be a lower bound and 5 would be our upper bound. So I'm going to say let's start with 5 first. We're going to do synthetic division on our function. So we're going to copy down all of our constants, all of our coefficients. And we're going to do synthetic division and take a look at the results. So we bring down mama, multiply and add. So we're going to have 10. When we add, I get a 3. Multiply, we get 15. When I add, I get 7. Multiply, we get 35. When I add, I get a 49. Multiply by 5, we get 245. And when I add, I get 253. And something that I want you to take notice of is your answers, your results here. All of these answers we can say are all positive numbers. They're all positive. If you get a result that results in all positive numbers, this is going to show you that 5 is an upper bound. So we can say no zeros past 5. Okay, and we're going to do the same thing now with the lower bound. So with the lower bound, we have -2, they're saying is our lower bound. And again, we're going to start back at that original function, copying down all of our coefficients, and we're going to do synthetic division. So we're going to bring down mama, multiply and add. So I have a -4. I add, I get a -11. We multiply, get a +22. We add and get a 14. We multiply to get a -28. We add and get a -14. We multiply to get a +28 and add to get a +36. So now if you look at this, this is different. They're not all positive. In fact, they go positive, negative, positive, negative, positive. That's what we want to see. So I can say here that they are alternating. I'm going to list them as non-positive and non-negative, because what that's going to do is account for what happens if you get a 0. Okay, non-positive, non-negative, they're alternating. So what this is showing us is so -2 is, in fact, a lower bound, meaning there are no zeros lower than -2. So we've just gone over synthetic division, how to do synthetic division, how to find some factors, how to test if it's a 0, and find upper bounds and lower bounds. I know that this is a lot. Again, we'll go through this in class and practice. Please feel free to let me know if you have any questions.